Have you ever wondered if it's possible to overload a black hole? Black holes, these mysterious celestial bodies, are born from the death throes of massive stars. They're so dense that their gravitational pull becomes inescapable, even for light. Yet, contrary to popular belief, black holes are not cosmic vacuums, indiscriminately gobbling up everything in sight. Instead, they're more akin to celestial whirlpools, ensnaring only those unfortunate enough to stray too close. Misconceptions about black holes are plenty. Some imagine them as voracious monsters of the cosmos, others as gateways to other dimensions. While the truth might not be as sensational, it's no less fascinating. These celestial enigmas challenge our understanding of the universe, pushing the limits of our knowledge and imagination. So, with that basic understanding of black holes, we can now explore the intriguing question: can we overload a black hole? As we delve deeper into this enigma, prepare to have your mind expanded by the wonders of our universe. To comprehend whether we can overload a black hole, we first need to understand how they interact with matter. Now, black holes are regions of space where gravity is so strong that nothing, not even light, can escape their pull. They're like cosmic vacuums, endlessly sucking in everything that ventures too close. However, the boundary where this gravitational pull becomes irresistible is known as the event horizon. Anything that crosses this point is irretrievably lost to the black hole. But what happens to all the matter that a black hole consumes? Well, it's a process called accretion. As matter spirals into a black hole, it forms a swirling disk around it. This is the accretion disk, kind of like the water swirling around a drain. The matter in this disk is heated to incredibly high temperatures, emitting radiation before it passes the event horizon and is swallowed by the black hole. And here's the fascinating part. As a black hole absorbs matter, it grows. Its event horizon expands, and its gravitational pull becomes even stronger. It's an insatiable cosmic beast, always hungry for more. But just like a person who eats too much might need to loosen their belt, a black hole that absorbs too much matter will expand. Its event horizon will grow larger, and so, in a way, the black hole becomes bigger. This doesn't mean that it's getting heavier, though. The total amount of matter, or mass, inside the black hole remains the same. It's just that the space it occupies becomes larger. So, black holes grow by absorbing matter. But does this mean they can absorb an infinite amount? Or is there a limit to how much a black hole can eat before it's full? And what would happen if a black hole did somehow manage to swallow all the matter in the universe? Would it become a supermassive black hole? Or would it simply explode from overeating? Well, these are the questions that keep astrophysicists awake at night. So black holes grow by absorbing matter. But does it mean they can absorb an infinite amount? Let's find out. Theoretical physics offers some interesting perspectives on our question. One such perspective comes from a concept known as the cosmic censorship hypothesis. This hypothesis postulates that a black hole, the universe's ultimate trash compactor, may indeed have a limit to how much it can absorb. The cosmic censorship hypothesis is a proposal by British mathematician Roger Penrose. Penrose suggested that there's a cosmic censor who forbids the appearance of naked singularities. Now, a singularity, in the context of black holes, is the point at the center of a black hole where gravity becomes infinite and space-time curves infinitely, and all our known laws of physics cease to be useful. In a normal black hole, this singularity is hidden behind an event horizon, a point of no return beyond which nothing, not even light, can escape. Hence, we can't observe it directly. However, if a black hole could be overloaded, if it could consume so much matter that it couldn't keep everything hidden behind its event horizon, we might end up with a naked singularity. This could potentially expose the universe to the strange and unpredictable effects of these singularities, and that's something the cosmic censorship hypothesis suggests the laws of the universe just won't allow. The cosmic censorship hypothesis, while not definitively proven, is widely accepted in the scientific community. It's a kind of safety mechanism, a rule that keeps the universe predictable and the laws of physics intact. It's a concept that suggests the universe has a way of protecting itself from its own extremes. This hypothesis suggests there might be a limit to how much a black hole can absorb. But what happens if that limit is reached? That's a tantalizing question, one that challenges our understanding of the universe and the nature of black holes. And it's a question we'll delve deeper into as we explore the consequences of overloading a black hole. So what happens if we hypothetically manage to overload a black hole? One might think that the more we feed a black hole, the larger and more destructive it gets. And to some extent, that's correct. As black holes consume matter, They do grow in size. But does this mean we can overload a black hole? Well, overloading in the traditional sense implies a breaking point, a limit beyond which a system fails or collapses. But when it comes to black holes, our current understanding suggests they might not have such a limit. Instead, the more matter they consume, the larger they get, potentially growing indefinitely. Imagine cramming all the matter in the universe into one black hole. It would become a supermassive black hole, millions or even billions of times the mass of our sun. In reality, such black holes exist at the center of most galaxies, including our own Milky Way. But what if we take this idea to the extreme? What if we keep feeding a supermassive black hole? Would it eventually explode or perhaps form a quasar? A quasar, short for quasi-stellar radio source, is an incredibly bright galactic nucleus powered by a supermassive black hole. These celestial bodies are among the most powerful, energetic, and bright objects in the universe. They emit enormous amounts of energy, equivalent to hundreds of galaxies combined. However, it's important to note that these are just theories based on our current understanding. As with many things in astrophysics, the consequences of overloading a black hole are speculative. Moreover, it's not even clear whether overloading a black hole is possible. Even if we could gather all the matter in the universe, it would be a monumental, if not impossible task to feed it into a black hole. The truth is, we don't know for certain what would happen if a black hole were overloaded. But exploring these questions helps us better understand the nature of our universe. So, can we overload a black hole? The current consensus in the scientific community suggests not. We've delved into the enigmatic nature of black holes, the interaction between black holes and matter, and the theoretical limits proposed by the cosmic censorship hypothesis. We've also pondered the potential consequences of overloading a black hole, yet the truth remains shrouded in mystery. This exploration, however, pushes us to expand our understanding of the cosmos. As we continue to explore and understand our universe, who knows what fascinating discoveries await us.